Hello friends, welcome back to CADCAM station. In this video, I'm trying to show you the practical application of CAMWORKS and SOLIDWORKS together to achieve this desired result. In this case, we have a cast iron workpiece as you can see on your screen, in which we have to perform a slot operation at an angle on vertical milling center. I will try to explain every process in this video, so make sure you watch this video till the end. So without wasting any time, let's get started. So guys, as you can see, we are working with Fanuc series 15M Kitamuras. So the condition of the machine is quite old, but we are still going to get the result out of this machine. So before starting any operation on this machine and putting the specimen onto the bed, what we have to do is to reference the machine or send the machine to its stock home position. And before doing this, what we have to do is, this is the mod knob, you can say that, and this is the reference jog. So this is how you can change the mod on this machine. So first of all, as you can see, we have set it onto the handle, and we are going to change the Y position, and I'm gonna rotate it a little bit, and under the machine value, as you can see here, I'm gonna change every value under the machine section to the negative value before sending the machine to its reference position. Now as you can see, X and Y are onto the negative values, and now the Z is also on the negative value. So after doing this, I'm gonna change the mod to the reference position, and after referencing it, I'm gonna send the machine to its stock position or a stock home position. Okay, for doing this, first of all, I'm gonna use the Z axis, and now the machine is going to its Z home position, now the Y, and this is the time for the X. So Z is on its position and Y and X almost on its position. So the machine is referenced now. So the job is on the bed, and as you can see there, I'm gonna place this job horizontally so that the marked surface is going to be parallel to the XY plane and the slot is facing towards the Z direction. So this is the way I want to place the job on the bed. As you can see here, this is the marked place we have to perform the cutting operation. So before doing this, we have to set XY0 at this point, so that by taking this as a reference, it will perform the cutting operation. So before doing this, we have set the dial gauge or puppet dial. So this surface is going to be parallel to the Y axis, and this surface is going to be parallel to the X axis. So after doing the job perfectly, I'm going to place the coordinate system 0 XY0 at this point, and taking this as a reference, I'm gonna project these punch marks into the software in order to generate the 3D model out of it. So guys, as you can see, we have successfully marked this position as a reference position for the machine, which is X0 Y0. And let me just show you on the screen of this controller. As you can see, X and Y is 0 now. So by taking this point as a reference, we are going to project these punch marks into the software. So let's just see how we're gonna do that. So guys, as you can see, we are inside the SolidWorks interface, and I'm going to start with the top plane. And as you know that this is the point, I'm considering it as the origin where X and Y equals to 0 that we have set onto the main component, and I'm going to project the points or the punch points which is exactly on the component, and by referring the relative value from the machine controller, and I'm going to put those relative values into XY coordinate. In this case, I'm going to take the value for the X point is 61.6, which I have taken from the machine controller, and for the Y axis it is going to be 1.5. 5 millimeter. So as you can see, this is the point on actual cast iron job. So the second point is 191.1, and the y is equals to, let me see on the machine, it is 80.4. So this is the second point which I am projecting in this software from the original component. So I am fixing it at the same point. So the third point is going to be 234.2 in the x direction, and y is going to be 42.6. So this is the point, and I'm gonna fix it as well. So this is the 3 points that I need to create the profile. So this is the, let me just change the color to red to see exactly where the points are. So far so good. So let me just enable the coordinate position. So this is the point which I am referring with respect to the original component. So I'm gonna again take the top plane and I'm going to join these points. So this is the point, or you can say that this is the one side of the slot. So I'm going to give the radius of 10 millimeter on this corner. Now what I'm going to do is I'm going to offset this line by the distance of 62 millimeter, which is required in this case, and I'm going to change its direction. So this is what we need. So far so good. So we need to close the slot. So in order to do that, I have to go back to the roll back to the previous sketch points. So I'm gonna place 2 more points. The first one is 72.1 and other one is going to be 57.6. so this is the closing point for the slot on one end, and another is going to be over here. So let me just put another value, 35.2, and let me just put this value as well, 14.3. so this is going to be the slot end. So now what we're going to do is I'm going to close the slot by draw the line, and I'm going to select this line and the point and making it midpoint. Do the same thing on the other point. So like this. Now what I'm going to do is I'm going to select this line and this line. I'm going to make it perpendicular. This line and this line I'm going to make it perpendicular as well. So now I'm going to take a circle command, 3-point circle, and I'm going to join these points like this. Now you can see that it is going to look like what exactly the slot shape on the original component or our job. So I'm going to trim out the lines which I don't need. If I trim this, the whole profile is going to be loose, or you can say that undefined. So in order to fully define, I'm just creating another line so I can trim it out without disturbing the points. So I can trim out the circle like this and this, and again I'm going to create a line and make it reference line, and creating another line like this in order to trim it or make a close profile. So we have the close profile as you can see here. So again I'm going to create a rectangular profile which is representing the part or the region at which we have taken the origin on our original component. So these are the dimensions of our original components. So let me just show you like this. So now what I'm going to do is I'm going to extrude it so that it kind of look like the original component that we are working on. So the extrusion height is going to be around, let me just put it over here, 71 millimeter. So this is the profile. We have extruded it. Now is the time to extrude the slot area. So let me just roughly draw and make these points coincident. So the length of this portion it doesn't matter, because we are only going to work on the slot feature. So now what we're going to do is I'm going to select the chain and convert entities so that we can get the slot extrusion like this. I'm going to change its direction, and the height is going to be 85 millimeter. One more thing, as you can see, this is two parts. Now I'm going to extrude it, move the face, translating it up to surface like this. So now it looks like we don't need to project anything downwards, because we are going to work only on this slot. So is the time to create the program in CAMWORKS. So as you can see, so I'm going to click on the machine settings. So I'm going to select mill matrix. In the post processor, I'm going to select the post processor of Fanuc 11M series, because this is the only processor which is working on my machine. So under the stock area, I'm going to create the sketch at the bottom by clicking on it and convert entities. So exit the sketch. Now I'm again going to click on the stock manager. So under this option, you can select the sketch, and up to surface you can select it, and this is the stock or the area up to which we have to work, and you can click OK. So now is the time to set the coordinate system. Click on the coordinate system. So the current position is at the bottom. We need at this point, which is select the entity and then select this point. So the position of y-axis is in the wrong direction, so I need to reposition it. So highlight the y and select the edge in which you want to position your y. So this is how you can see. This is what exactly the position on our original object. So now setup. So now set the mill setup. So select the face in which direction the Z or the tool is coming from, like this. So everything is ready. Now is the time to set the multi-surface feature. You can click 2.5 as well, but I preferred multi-surface feature. So now click OK. So now we have set the feature. Now is the time to go on to the next option, which is creating the Z level operation. So at this point you have to select the tool. If you can't see your tool right now, you can change the tool in the next pop-up window. Under the feature, you can select the multi-surface feature which you have created. So now on this screen you can change the tool and its all parameters. If you know the parameters, which is good. If you don't know, you can simply enter the shank and tool diameter and leave the other things as it is. It doesn't matter actually. So this is the comment you can write for the tool. It is not going to affect anywhere. So these are the feed speed options. So spindle RPMs I'm entering here, and here XY movement of our tool is going to be like this. The XY allowance is what you mean is to left the material after cutting, so I'm going to leave it as 0 here. So cut type is Z level and cut amount is 0.2. So the direction of cut is climb. Under the NC operation, I'm going to leave it as it is. Links are nothing to change over here. Leave the settings as it is. and ramping is required, so leave it as it is. So I'm gonna change the value from here. This portion helps you to rotate your tool in arc with perfect motion, so this is required, and the rest of the thing, it should be, you should leave it as it is. Now you can click OK. But before clicking on post processing, I'm going to create a contain area, so on which we have to perform operation. So this is the slot on which we want to perform an operation, so select it and click OK. Now right click, and now you can generate the toolpath. It will take some times, so at the end you will get your toolpath ready. And let's see what it gives you. So this is the toolpath that we get with the constant Z or Z level machining. So I guess we are good to go. Now what I'm going to do is I'm going to create GM codes by clicking on post processor, select your save path. I'm going to select the desktop and name whatever you want to name it, but in this case I'm going to enter the name according to the tool we are using. Now you can click on save. On the next window you can click on these options and open GM codes in, and then you can click on play. So like this, clicking on OK. Now you can see we are inside the NC editor, CAMWORKS NC editor. So this is your GM codes ready to import into the machine, and now after importing this GM codes into the machine, you are ready to start working on your project. So let me just show you how I can get these GM codes into the machine by using thumb drive. So copy it from your desktop to the thumb drive and then put it into the machine controller. So guys, as you can see here, the job is ready and the tool is on its position ready to work on this slot. The machine is also ready. As you can see, I have placed all the machine value into the G54 section over here so that the machine can run according to our set position. Okay, so this is the drip feeder which we have attached to this controller, which allows us to use the thumb drive to feed the program into the controller, which helps us to run the machine with good efficiency. So I'm going to copy the program from the pen drive or thumb drive and paste it inside the memory of this device. So the program is loaded, the machine is set. We need to set it onto the tape, as you can see over here, which helps us to run the program through this device. So now all I need is to start the cycle and control it. So this is, as you can see here, the program is perfectly running. But let me inform you that this is not the final program. We have to make some adjustment in order to run the program according to what we need here. So let me show you. Under the feed speed, everything is perfect, I guess. So under the Z level, we have add the XY alliance 1.5 millimeter. Instead of climb, we have selected the conventional, and under the cut method we have select helical. So the depth of cut is 0.3, and NC is good, everything is good. And entry and retract option, we have selected the lead out radius, which is going to be equals to 2 millimeter, as you can see over here. So this is what we have set, because we need to retract the tool while it is coming out of the slot. We need the tool to move away from the slot first, wall of the slot, and then come back to its home position. This is what we needed. So you can say this is the final output we are taking from the CAMWORKS as a program. Now you can see here the program is running perfectly on the slot, and I hope you guys found this video very informative, and if you still have some question in your mind, so please let me know into the comment section, and I will definitely going to put some more videos like this in the future. So make sure you subscribe to my channel, hit the bell icon so you never miss the upcoming updates. Stay tuned for more. Keep watching CADCAM Station. Signing out for now.